Okay, Algebra 2, Mod 8. It is now Wednesday, April 1st. We've got another similar topic today. The title actually says, One More Type of Rational Function. So everybody, Mod 8, Algebra 2 guys, phones away, TV off, distractions away. Focus for about 10-12 minutes here on me teaching you one more type of function to graph. Your job is to get out a sheet of paper, put the date up in the corner, April 1st, 2020. Put the title up in the margin called One More Type of Rational Function. And we're going to try to graph the following 4 problems on our notes. And when we're done, hopefully, again, it's well explained, well instructed, you'll focus, pay attention, and understand, and prove whether you do understand it or not by doing a little 4-problem homework assignment that you'll take a picture of and email to me by tomorrow at noon on Thursday, April 2nd, okay? And we'll keep doing a daily grade based on the completion and correctness of your homework on a daily basis. All right, today's notes. Problem number 1. It says y equals x plus 4 over x minus 3. And we're going to try to graph this problem. Well, again, notice this is a fraction, isn't it? So it's still called a rational function, just like the last 2 days. And just like the last 2 days, we're going to find what we've been calling a what? A VA, a vertical asymptote, by simply looking at the denominator. So I'm going to ignore the numerator for a second and ask you this question again. What number could I plug in for that x that's going to cause the entire denominator to turn into the number 0? Well, of course, if I plugged 3 in, isn't 3 minus 3 going to give me 0? So my vertical asymptote is at 3, at x equals 3. So I now know picture-wise, I can go over to 3 and draw an imaginary vertical line. Remember, it's kind of like an invisible force field going right through the number 3. So that part has not changed. 2 days ago, when there was nothing special about the problems, we had to pick 3 numbers to the right and plug them in one at a time. And then remember, we had to pick 3 numbers to the left and plug them in one at a time to draw a curve on each side of that asymptote. Yesterday, there was a number tacked on at the end, like +1 or -2. And whatever that number tacked on at the end was called a transformation. And it determined where our horizontal asymptote was going to be. And then we just had to pick 1 point on each side to sketch a picture. Remember all that? Well, today, notice there is not a number tacked on at the end, but there is a trick I can show you that's going to allow you to figure out where the horizontal asymptote it is. And here's the trick. Here's all you've got to do. To figure out your horizontal asymptote, all you've got to do is go back up to the original problem and look at the number that's in front of each of the x's. This x has a 1 in front of it, and the bottom x also has a 1 in front of it. So we literally take that 1 and put it over top of that 1, and 1 over 1 gives us 1. And I'm going to go up to the number 1 and draw my horizontal asymptote right through there. So now all I need, just like yesterday, is to pick 1 dot to the right and 1 dot to the left of this vertical asymptote to sketch a picture that fits on each side. So if I make a little table here, give me a number that's to the right of that asymptote. You'd all say what? 4. Now take 4 and go plug it into that problem. I'd have 4 plus 4 on top, which would be what? 8. I'd have 4 minus 3 on bottom, which would be 1. So 8 over 1 gives me 8. So I'm going to go right 4 and up 8, way up here somewhere. And so now to draw my picture, I'm going to get close to the vertical asymptote there. I make my way down a little bit at a time and draw a horizontal value there, and my curve fits up in that little section. Give me a number to the left of the vertical asymptote. I would think everybody would pick what? 2. Go plug 2 into the problem. 2 plus 4 is what? 6. 2 minus 3 would be -1. 6 over -1 gives me -6. So I'm going to go right 2 and down 1, 2, 3, 4, 5, 6. Notice again, it's going to get really close to the vertical asymptote, and it's going to swing upwards slowly but surely and eventually get close to the horizontal. And you draw your curves in that situation. Okay? Let's try another one. Look at the next problem. Watch how easy this really is once you get the hang of it. The vertical asymptote is found by picking the number that turns the bottom into 0. Does everybody agree that would be the number 5, right? Because 5 minus 5 gives me 0. I'm not even looking at the numerator. 5, we all agree, is our vertical asymptote. So I'm going to go right 5 and draw a vertical asymptote through that number. So far, so good. The horizontal asymptote on this kind of a problem, when there's not a plus or minus tacked on at the end like yesterday, remember what number is in front of the x up top? 2. And what number is in front of the x on the bottom? 1. And 2 over 1 gives you 2. So my horizontal asymptote goes right through 2. So here we go. Somebody pick a number to the right of that vertical asymptote. Since that's on 5, we of course would pick 6. Plug that into the original problem. 2 times 6 is what? 12 minus 4 gives me 8. 6 minus 5 gives me 1. 8 over 1 would be 8. So write 6 way up here at 8. You would draw a sketch that looks like this. And then pick a number to the left of that asymptote, which would be 4. 2 times 4 is 8, minus 4 is 4. 4 minus 5 is -1. 4 over -1 gives you -4. So I go right 4 and down 4. And all I need is that one dot to draw a curve close to him, and then a curve that would again eventually swing way up there and get close to him. And your picture's finished. You just got to know which section your curve is located in by picking what we call our 2 little test points. Okay? The third one, if we take a look at this one, the vertical asymptote would be what? Everybody agree? Think about it. What would you write down? Wouldn't it be -1? Because -1 plus 1 creates a 0 on the bottom. The horizontal asymptote, what number is next to x up top? 5. What number is next to x on the bottom? 1. And 5 over 1 would be 5. So, here we go. I've got a vertical asymptote this time at -1. So that's over here, right? Let me make sure you can see that. I put a vertical asymptote through -1. I've got a horizontal asymptote up on 5, which is right here. And I need to draw my curve now, or curves, in the proper sections. So, picking a number to the right of the vertical asymptote, wouldn't you choose 0? Let's plug 0 in. 5 times 0 is 0, plus 6 is 6. 0 plus 1 is 1. 6 over 1 is 6. So I'm going to go right 0 and up 1, 2, 3, 4, 5, 6 right there. So that'd be easy to draw a curve close to that dotted line. Close to that dotted line. Give me a number to the left of that vertical asymptote, right? Wouldn't you pick -2? Plugging that into the original problem, 5 times -2 is -10, plus 6 would be -4. -2 plus 1 would be -1. A negative over a negative is a +4. So I'd go left 2 and up 4. There's my one key dot. That's all I need, believe it or not, because now he's going to do what? Get close to that wall, get close to that wall, and my picture is done. One more to go, and after 3 days of 3 different types of rational functions, you should be an expert on this. Okay, our last one. My vertical asymptote would be, think about it, what would you put for the vertical asymptote? Think. Wouldn't it be 2? Because 4 times 2 is 8. 8 minus 8 would create 0 on the bottom. My horizontal asymptote, now be careful, what number is in front of the top x? 1. What number is in front of the bottom x? 4. So I actually have a horizontal asymptote at 1/4. So when I draw my picture here, I've got a vertical asymptote running up and down that goes right through 2. I've got a horizontal asymptote running sideways that goes through 1/4. That's not very tall, is it? It's 1/4 of an inch above the x-axis. So now when I make my little table here, give me a number to the right of the vertical asymptote. I would assume everybody would pick 3. Plug that into the original problem. 3 plus 6 is 9. 4 times 3 is 12, minus 8 is 4. I actually get 9 over 4, which is what? 2 1/4. So I'm going to go right 3 and up 2 1/4. Draw a curve situated up in this section. Give me a number to the left of that vertical asymptote. You would all pick 1. Plug 1 into the original problem. 1 plus 6 is 7. 4 times 1 is 4, minus 8 is -4. 7 divided by -4, if you did that on your calculator, would be -1 3/4, -1.75. So I'm actually going to go right 1 and down 1 3/4, right about there. So he would get close to the vertical asymptote there, swing up and about, and get close to the horizontal there. Notice how similar all these pictures are in terms of being reflected curves of each other. It's just up to you to take your time, pay attention to the details, and get those curves to end up in the correct spots. Okay? That's our last day of rational functions. You're going to have a homework assignment here. Try 4 of these on your own and email them back to me after you take a picture of your 4 finished problems, okay? So guys, Algebra 2, April 1st. These are not due to my email until the next day, which would be Thursday, April 2nd by noon, and see if you can practice and correctly do these 4 problems. Number 1 is x minus 1 over x plus 5. Number 2, 4x minus 11 over x minus 2. The third one is 8x plus 3 over 2x minus 6. And finally, number 4, 2x plus 1 over x minus 3. Hopefully that makes sense. You can do those tonight, and we'll start a brand new unit, a brand new chapter tomorrow on Thursday, okay? Thanks. See you then.